Hey math fans, welcome to the video over solving quadratic equations by factoring when a equals 1. So before I get into any solving, I just want to go over what it means to solve a quadratic equation. When you solve a quadratic equation, basically you're looking for where it hits at the x-axis, okay? These are called your x-intercepts. They also go by roots, solutions, and then they're also called the zeros. They're called the zeros because the where you hit on the x-axis, that's when the y coordinate is 0. Okay. Um, so there can be two solutions, there could be one solution, and then there can be zero solutions. And if there's zero real solutions, then you'll have to calculate the imaginary solutions, is what we call them. But that would be for a different video, okay? Today we're just going to factor and solve. We're going to get either two solutions or possibly one solution, okay? But if a function doesn't factor, that doesn't mean it's not solvable. It just means it can't factor. There's a bunch of different ways you can solve a quadratic equation. Factoring is just one way of solving an equation. Okay, so I'm going to do these two problems here, and going to do them very step by step. The first thing you want to do is you want to make sure that they are all in standard form. That means everything is on one side of the equal sign and the other side equals 0. Okay, so I wrote down all the steps here, and I'm just going to kind of verbally go over them, and I'll just work things out over here. But step one would be to minus 5 to the other side to get everything over on one side. And on this one, I would minus 10x to the other side. And both of these equations, they're all separate terms, meaning unlike terms, I should say. Meaning they will stay separate from one another. They won't combine. Like I won't say minus 4x minus 5 equals minus 9x because the 4x has an x and the 5 doesn't. And so if I minus 10x, that'll go in the middle because it can't combine with something that's being squared. So this is my bx term, and it can't combine with the 21 that doesn't have a letter at all because that's my constant term. Okay. And step two will be to do the a coefficient times the c. Now, in all these examples in this video, the a coefficient is going to be a 1. Okay. Um, in other videos, a will be equal to some other number other than 1. Okay. Uh, but what you want to do is you want to go a times c. So 1 times negative 5, that's negative 5. What are the factors of negative 5 that add up to your middle term of negative 4? Don't worry about the x. Don't ask yourself, what multiplies to get negative 4x? No, no, no. Just negative 4. So what multiplies to get negative 5? I said that kind of weird. What multiplies to get negative 5 and adds to get negative 4? That will be negative 5 and 1, right? Negative 5 plus 1 is negative 4, and negative 5 times 1 is negative 5. Okay, so it's got to satisfy that question. It's got to satisfy both scenarios. Okay, so on this one on my right, what 1 times 21 is 21. So what are the factors of 21 that add up to negative 10? And so 21 could be 21 and 1 and 7 and 3. And they both got to be negative because it's got to add to get negative 10. So clearly I'm going to use 7 and 3, negative 7 and negative 3, because those add up to negative 10. Whereas if I used negative 21 and negative 1, that would add up to negative 22. So that wouldn't work out. Okay. So I'm going to use negative 7 and negative 3 on the one on the right, and then I'm using negative 5 and positive 1 on the one on the left. So once you identify the factors that satisfy the scenario, what are the factors of the a times the c term that add up to the b term, you can go ahead and factor it, okay? When you factor it, you put it in these things called binomials, where it'll say x plus a number in parentheses or x minus a number in parentheses. And then it's going to equal 0 because you're essentially just transforming your equation into a factored form. You're not changing any of the attributes of the function, like the graphs are still going to be exactly the same. So if the graphs are still the same, then they're basically the same, congruent, equal, however you want to phrase it. But anyway, back to this. If I'm using -5 and +1, I'll say x minus 5, x plus 1. If I'm using -7 and -3, this will turn into x minus 7 and x minus 3. Okay, so this is called my fully factored form. This is an important step because um, usually there'll be at least one test question that'll be like, what is the factored form of, and they give you an equation. Okay, you're not completely done yet, but the factored form is an important step because the whole reason why we factor is you can take these binomials, again, the binomials, the stuff that's in the parentheses, and you can set them equal to 0. So I'll be like, what's x minus 5 equal to 0? What's x plus 1 equal to 0? These are simple equations that you can kind of easily solve, and that's the whole reason why we factor is because these equations are easy to solve, so therefore we can kind of quickly identify what the x-intercepts are. Whereas if it were in standard form and you were to try and solve it without factoring, it would take a bit more steps, okay? Factoring is supposed to be kind of like a shortcut kind of method, all right? So if I have x minus 5 equals 0, then I know I can just add 5 to the other side, and I get x equals 5. If I have x plus 1 equals 0, I know I can just minus 1 to the other side, and I get x equals -1. All right, these are your solutions, your x-intercepts, your zeros, your roots. That's where it touches on the x-axis. Okay, that's what we're looking for. All right, if you were to write these as a coordinate, they'd be like 5 comma 0 and -1 comma 0. But usually just saying x equals 5, x equals -1 is good enough. But if your teacher ever asks you for the answer in coordinate form, you just make the y coordinate 0 because remember you set the whole thing equal to 0. All right. Anyway, back to these. If I have x minus 7 equals 0, I could just, add 7 to the other side. A lot of kids like to just say, I'll just flip the sign, right? If it's -7, then it'll be +7. If it's -3, then it'll be +3. So this will be +3. So whatever makes sense to you. If you need to show the work, go ahead and show the work. But yeah, 7 minus 7 equals 0, 3 minus 3 equals 0. So those are the solutions to that one on the right, okay? And that's basically all there is to say about that. So I have one more example here, and you can see that I have a bunch of things on each side of the equal sign. What I recommend doing is get it to the side where your x squared term will be positive. So I see a 6x squared on the left and a 7x squared, 6x squared on the right and a 7x squared on the left. I'm going to want to move that 6x squared over. So since it's positive, I'll minus it. And the reason why I'm moving that one is 7's bigger than 6. So if I do 7x squared minus 6x squared, I'll get a positive 1x squared. Okay, you can put the 1 by it if you want, but it's not really necessary. Okay, so that cancels out over there. So because I moved that x squared over to the left, I'll move this 9x term also over to the left. And I'll put it under the 10x because that's its like term. Okay, so 10x minus 9x is positive 1x. So you could just put plus x or you could put plus 1x, whatever makes you happy. But since that's gone, now my equation equals 0, which is what you want to happen. So we'll just go ahead and bring down this minus 42, okay? And so the next step would be to ask yourself, what are the factors of 1 times -42? So what are the factors of -42 that add up to your middle term of 1, okay? So I'll make a little list here. It's -42 and it's going to add up to a positive 1. So that means the bigger factor will be positive, and the smaller factor will be negative. So like 42 and 1, we got 21 and 2, we got 14 and 3, we got 7 and 6, I think that's all of them. But let's see here. So if we're gonna make the smaller one negative, this will add to get 41. This will add to get 19. This will add to get 11, and this will add to get 1. So my numbers that I'll use are going to be 7 and -6. So I will turn this into, I'll put it right here, x plus 7 since it was a positive 7 and x minus 6 since it was a -6 equal to 0. Okay, this is the fully factored form. Take each factor and set it equal to 0. Take each binomial, I should say, set it equal to 0, and then you could simply just kind of flip the sign, or I'll show my work. Okay, so I would minus 7 over because it was a plus 7, and then here I would add 6 over because it was a minus 6, because I got to do the opposite sign to get it to the opposite side. And so I'll get x equals -7 and x equals positive 6. Those are my two solutions. Again, this is the fully factored form. And that's going to do it for these notes. So thank you for watching. Hope you learned something, and goodbye.